We interact with countless electronic devices daily. From smartphones to smart refrigerators, these devices have become indispensable. But have you ever stopped to wonder what makes them tick? Behind the sleek screens and responsive buttons lies a hidden world of intricate circuitry and software. At the heart of this hidden world lies firmware, a special kind of software that gives life to electronic hardware. It's the silent orchestrator, ensuring that our devices function seamlessly and perform as expected. Without firmware, even the most sophisticated hardware would be nothing more than an inert collection of components. Firmware acts as a bridge between hardware and software, translating our commands into actions that the hardware can understand. It's the invisible force that powers everything from the simplest microwave oven to the most complex spacecraft. In this exploration of firmware, we'll demystify its workings, understand its importance, and delve into the fascinating world of how it's created and its impact on our increasingly digital lives. Imagine a sophisticated robot arm designed for intricate surgery. It possesses powerful motors, precise sensors, and a complex mechanical structure. However, without firmware, this marvel of engineering would remain lifeless, unable to move a single joint. Firmware acts as the robot arm's brain, providing the intelligence and instructions needed for it to function. It interprets commands from surgeons, controls the motor's movements, and processes data from sensors, ensuring both precision and safety during surgery. In essence, firmware breathes life into hardware. It provides the necessary instructions for hardware components to interact and work together harmoniously. Without it, our devices would be like orchestras without conductors, capable of producing sounds but lacking the coordination to create a symphony. From controlling the temperature in our refrigerators to managing data storage in our smartphones, firmware plays a crucial role in shaping our interactions with technology. It's the unsung hero that makes our digital lives possible. Firmware resides in non-volatile memory within electronic devices, meaning it retains its instructions even when the device is powered off. These instructions, written in specialized programming languages, form the blueprint for the device's operation. When a device is powered on, the firmware comes alive. It initializes the hardware components, checks for errors, and prepares the device for use. Once operational, the firmware continuously runs in the background, responding to inputs, managing tasks, and ensuring smooth operation. Think of firmware as a conductor leading a symphony orchestra. Each instrument represents a hardware component, and the conductor's instructions represent the firmware's code. The conductor guides each instrument to play its part at the right time, creating a harmonious melody. Similarly, firmware orchestrates the interaction of various hardware components, ensuring they work together seamlessly. The complexity of firmware can vary greatly depending on the device's functions. A simple coffee maker might have relatively straightforward firmware, while a smartphone requires a sophisticated operating system with layers of firmware managing different aspects of its operation. While firmware is designed for reliability, errors can occur, leading to malfunctions and unexpected behavior. These errors, often called bugs, can arise from various factors, including programming mistakes, hardware failures, or unforeseen interactions between different components. A bug in the firmware of a car's engine control unit could lead to reduced performance, increased emissions, or even safety hazards. Similarly, a faulty firmware update on a smartphone could render it unusable, requiring technical assistance to restore. Firmware errors can be frustrating and sometimes dangerous, highlighting the importance of robust development processes and thorough testing. Developers employ rigorous debugging techniques to identify and eliminate errors before firmware is released. Moreover, manufacturers often release firmware updates to address bugs, improve performance, or add new features to devices. These updates are essential for maintaining device functionality and security. Section 5. Firmware's ubiquitous presence from microwaves to Mars rovers. Firmware is everywhere in our increasingly digital world. It's the hidden force that powers a vast array of electronic devices, from everyday appliances to sophisticated scientific instruments. Its ubiquity underscores its critical role in modern technology. Consider the humble microwave oven. Firmware dictates the power levels, cooking times, and sensor readings that ensure your food is heated to perfection. Without it, the microwave would be nothing more than a metal box with a heating element. At the other end of the spectrum, complex spacecraft rely heavily on sophisticated firmware for navigation, communication, and scientific data collection. The Mars rovers, for instance, depend on intricate firmware to traverse the Martian terrain, operate scientific instruments, and transmit data back to Earth. Firmware is the invisible hand guiding the operation of countless devices, making our lives easier, safer, and more connected. Section 6. The language of firmware: C, assembly and beyond. Firmware developers use specialized programming languages to write the instructions that control electronic devices. These languages are chosen for their efficiency, ability to interact directly with hardware, and suitability for resource-constrained environments. C is one of the most widely used languages for firmware development. It offers a balance of high-level abstractions and low-level hardware access, making it suitable for a wide range of devices. Assembly language, a low-level programming language that directly corresponds to a device's machine code, is often used when precise control over hardware is required. While powerful, assembly language is more complex and time-consuming to write than higher-level languages like C. In recent years, newer languages like Python and Rust have gained traction in firmware development, offering features that enhance developer productivity and code safety. However, C and assembly language remain the dominant languages in the firmware world. Choosing the right programming language for firmware development depends on factors such as the device's complexity, performance requirements, and the developer's expertise. Section 7. Creating firmware, a glimpse into the development process. Developing firmware is a complex and iterative process that involves multiple steps, from understanding the hardware specifications to rigorous testing and debugging. Firmware engineers begin by thoroughly analyzing the hardware they'll be working with, understanding its capabilities, limitations, and communication protocols. Next, they design the firmware architecture, defining how different modules will interact and communicate. This stage involves choosing the appropriate programming language and development tools. The actual writing of firmware is just one part of the process. Extensive testing and debugging are crucial to ensure the firmware functions correctly and meets the device's requirements. Once the firmware is deemed stable, it's deployed to the device. This often involves using specialized tools to program the firmware onto the device's non-volatile memory. Firmware development is rarely a solo endeavor. Teams of engineers often collaborate on projects, bringing their expertise in various areas to ensure the creation of robust and reliable firmware. Section 8. The future of firmware, trends and transformations. The world of firmware is constantly evolving, driven by advancements in hardware, software, and the increasing demand for smarter and more connected devices. The Internet of Things, or IoT, is a significant driver of innovation in firmware development. As more devices become interconnected, firmware must be designed to handle network communication, data security, and interoperability challenges. Artificial intelligence, or AI, is also making its way into firmware, enabling devices to learn from data and make intelligent decisions. This trend is leading to more sophisticated and autonomous devices. Security is paramount in firmware development, especially as devices become more connected and vulnerable to cyber attacks. Firmware engineers are increasingly incorporating robust security measures to protect sensitive data and ensure device integrity. The future of firmware is bright, filled with opportunities to create innovative solutions that will shape the future of technology and our interactions with the digital world. Section 9. Conclusion. Firmware, the unsung hero of the digital age. Firmware, though often hidden from view, is the unsung hero of our increasingly digital lives. It's the invisible force that breathes life into the electronic devices we rely on daily, from our smartphones to our cars, and even our coffee makers. Understanding how firmware works gives us a deeper appreciation for the complexity and ingenuity behind the seemingly simple devices we often take for granted. It also highlights the crucial role of firmware engineers, the skilled professionals who write the code that powers our digital world. As technology continues to advance at an unprecedented pace, firmware will continue to play a pivotal role, shaping the future of innovation and connecting us to a world of possibilities.